1,000 rockets per year. That's Elon Musk's audacious vision for SpaceX's Starship program. A launch cadence that would completely transform humanity's access to space. But there's been a critical bottleneck standing in the way: launch infrastructure. You see, SpaceX has been rapidly developing Starship prototypes, pushing the boundaries of what's possible with each iteration. But without enough launch towers, even the most advanced fleet of rockets would sit grounded, waiting their turn. A single launch tower requires extensive refurbishment after each mission. Cooling systems checked, structural integrity verified, and launch mount repairs completed. The turnaround time is simply incompatible with SpaceX's ambitious launch schedule. Now everything is about to change. SpaceX has been quietly working on a second launch tower at Starbase, featuring a revolutionary Chopstick system, massive mechanical arms designed to catch returning super heavy boosters in Starship's midair. This engineering marvel stands nearly 479 feet tall and represents the future of rapid rocket reusability. While Pad A has already undergone initial testing, Pad B is now entering its critical testing phase with significant upgrades that could dramatically accelerate the Starship program's timeline. Welcome to Elon Musk 24 Hours, your front row seat to the future of space exploration. Let's dive right in. The engineering marvel of Pad B. On February 12th, SpaceX engineers reached a critical milestone with the installation of the actuator system for Pad B's Chopsticks. These aren't your ordinary actuators. They're massive, precision-engineered components designed to control the movement of mechanical arms that will eventually catch a 165-foot-tall, 100-ton booster returning from space. The actuators must provide enough force to move the Chopstick arms with millimeter precision while handling the enormous weight of a Starship or Super Heavy booster. SpaceX likely opted for hydraulic power systems, given the immense force requirements. For perspective, each Super Heavy booster weighs approximately the same as a fully loaded Boeing 747, and these arms need to catch it mid-descent. Behind the scenes, SpaceX engineers have worked around the clock, implementing sophisticated counterweight systems and stabilizers. These components ensure the arms maintain perfect balance during operation, preventing unnecessary structural stress that could compromise the entire tower. 5 days later, on February 17th, another breakthrough occurred when the team installed the ramp systems. These precision-engineered guides are crucial for maintaining smooth, controlled movement of the Chopsticks. Think of them as the rails on which these massive arms will travel, except they need to handle forces equivalent to catching a falling skyscraper. That same day, protective cladding systems were moved into position. This might seem like a minor detail, but it's absolutely vital. The cladding shields critical components from the harsh South Texas environment, from hurricane-force winds to salt-laden coastal air that would normally corrode exposed metal within months. The first movement, a historic moment. The real excitement came later that evening when SpaceX conducted the first functional test of Pad B's Chopstick system. Engineers meticulously removed the safety tethers that had been securing the arms since their installation. These tethers weren't just for show. They prevented potentially catastrophic, unplanned movement during construction. As the Texas sunset painted the sky, the left arm of the Chopstick system moved for the first time. The movement was deliberately slow and measured. This wasn't about speed yet, but precision. Even at this cautious pace, the smooth motion validated months of engineering work, confirming that the joint mechanisms, actuators, and support systems were functioning in perfect harmony. What many observers might have missed is that Pad B's Chopsticks represent a significant evolution from Pad A's design. In a conversation with Everyday Astronaut, Elon Musk revealed that these new arms have been completely redesigned to be more compact and efficient. The engineering team shaved off unnecessary bulk while simultaneously improving agility and performance. A classic SpaceX approach of rapid iteration and improvement. The goal behind these refinements is clear: to make the catching process more reliable. When you're attempting to catch a 230-foot-tall rocket, traveling at speeds that would get you pulled over on most highways, every improvement in precision matters. If these design enhancements perform as expected, they could make Starship landings significantly more consistent, further reducing turnaround time between flights. Narshun, the road ahead, testing and validation. SpaceX's testing roadmap for Pad B is comprehensive and methodical. The next phase will involve testing the right arm's movement capabilities, followed by a complete choreography of both arms working in tandem, lifting, lowering, and rotating through their full range of motion. Perhaps the most critical upcoming test will be the weight pressure evaluation. SpaceX plans to attach massive water bags to the chopsticks, simulating the exact weight distribution of a returning Starship. These tests will reveal whether the arms can handle the tremendous forces involved when catching and stabilizing a vehicle that's just returned from orbit. For additional realism, SpaceX may employ specially designed test tanks to mimic a Starship's aerodynamic properties and mass distribution. These simulations will provide crucial data on how the chopstick system responds to different landing scenarios, from nominal approaches to edge cases where the returning vehicle might be slightly off-center. The testing process is painstaking because the stakes couldn't be higher. A single failure during an actual catch attempt could result in the loss of $1 billion launch system and potentially endanger the entire Starbase facility. The timeline. When will we see the first catch? Based on current projections, Flight 8 is scheduled for March, with Flights 9 and 10 following in April and May respectively. If all goes according to plan, Flight 10 could mark the historic first attempt at a full chopstick catch, a moment that would revolutionize spaceflight economics. Before this milestone can be achieved, SpaceX needs to perfect its landing techniques. Currently, super heavy boosters are performing controlled splashdowns in the Gulf of Mexico rather than returning to the launch site. This conservative approach minimizes risk while gathering critical data on booster reentry dynamics, descent profiles, and control system performance. The ocean landing strategy serves an important purpose. If a booster were to experience a major failure or navigation error, it would happen safely over open water rather than near Starbase's critical infrastructure. Once SpaceX has collected sufficient data and refined their algorithms, these landings will transition to precise, controlled descents ending at the launch tower. The same evolutionary approach applies to the Starship upper stage. The vehicle must develop incredibly accurate landing capabilities to be caught by the chopstick system. We're talking about threading a needle while riding a hurricane. The navigation and control systems must function flawlessly under extreme conditions. Flight 8, the next big test. Flight 8 represents a critical stepping stone in this journey. SpaceX is expected to conduct another super heavy booster landing attempt using Booster 10, incorporating lessons learned from previous flights. Unlike earlier test missions, this flight will include something new, a simulated payload deployment. This addition is significant because it reflects SpaceX's transition from pure testing to operational capability demonstration. A successful payload deployment simulation would demonstrate that Starship is nearing readiness for commercial missions, delivering satellites, supplies, or eventually humans to their destinations. The flight will also feature crucial re-entry tests focusing on heat shield improvements. During Flight 7, Starship's heat shield sustained damage from plasma heating in extreme re-entry conditions, a normal challenge when developing spacecraft that must withstand temperatures exceeding 2,700 degrees Fahrenheit or 1,500 degrees Celsius. In response, SpaceX engineers have redesigned portions of the thermal protection system. Flight 8 will validate whether these upgrades can withstand the intense heat and aerodynamic forces experienced during atmospheric re-entry. A successful demonstration would clear another major hurdle on the path to full reusability. The challenges beyond engineering. While making remarkable technical progress, SpaceX is navigating complex legal challenges in Texas. Environmental lawsuits filed by conservation groups and local organizations have created regulatory headwinds for the Starship program. These groups argue that Starship launches and related activities are negatively impacting the Boca Chica region's sensitive ecosystem. The area surrounding Starbase hosts protected wildlife species, including the piping plover, a threatened shorebird that nests on nearby beaches. Activists have expressed concerns about habitat disruption, noise pollution from launches, and potential ecological damage from test failures. Land use conflicts with Texas state agencies and private landowners present additional complications. As SpaceX expands its footprint to accommodate increased launch cadence, these disputes have intensified. The company must balance its ambitious technical goals with environmental stewardship and community relations. Despite these challenges, SpaceX continues pushing forward with remarkable determination. The company's approach to problem-solving, tackling multiple challenges simultaneously rather than sequentially, has allowed the Starship program to maintain momentum even as it navigates these non-technical obstacles. The technical evolution of the Chopstick system. The Chopstick system represents a fundamental rethinking of how rockets return to Earth. Traditionally, reusable rockets like Falcon 9 use landing legs to touch down on a designated pad. While effective, this approach requires significant post-landing processing before the vehicle can fly again. SpaceX's Chopstick catch mechanism eliminates many of these steps. By catching the rocket before it touches the ground, the system prevents landing leg deployment, reduces potential damage from landing forces, and positions the vehicle for immediate integration with ground systems. The arms themselves are engineering marvels. Each one consists of a primary structural truss designed to distribute massive loads, actuators that provide precise movement control, and specialized contact surfaces engineered to grip the rocket without damaging it. Computer simulations have played a crucial role in developing this system. SpaceX engineers have run thousands of scenarios modeling different approach velocities, wind conditions, and vehicle states to ensure the Chopsticks can safely catch Starship under almost any reasonable circumstance. The control systems governing the Chopsticks are equally sophisticated. They incorporate multiple redundancies, fail-safe mechanisms, and real-time adjustment capabilities. If the approaching rocket deviates slightly from its expected trajectory, the arms can adapt within milliseconds to ensure a successful catch. This technology didn't emerge overnight. It represents years of iterative development, with each design building on lessons learned from previous versions. The current Pad B implementation incorporates improvements from Pad A's initial tests, creating a more reliable and efficient system. When fully operational, the Chopstick system will enable turnaround times measured in hours rather than days or weeks. This capability is essential for SpaceX's long-term vision of making space travel as routine and reliable as commercial aviation. As we've seen, SpaceX isn't just building rockets. They're reinventing the entire launch paradigm. The dual-tower system at Starbase represents a critical turning point in spaceflight economics. With each successful test, we move closer to Elon Musk's vision of making humanity a multi-planetary species. The implications extend far beyond technical achievements. When fully operational, this system could reduce launch costs by orders of magnitude, opening space access to applications we haven't even conceived yet. From orbital manufacturing to deep space exploration, the infrastructure being built today will enable tomorrow's breakthroughs. What we're witnessing at Starbase isn't just another incremental improvement. It's a fundamental transformation in how we access space. As Flight 8 approaches in March, followed by Flights 9 and 10, we'll continue tracking every development in this extraordinary journey. If you found this analysis valuable, help us continue bringing you the latest SpaceX developments by hitting the like button and subscribing to Elon Musk 24 Hours. Share this video with fellow space enthusiasts who appreciate the engineering brilliance behind these achievements. What aspect of the new launch tower are you most excited about? Drop your thoughts in the comments below. I read every single one and love discussing these technological marvels with our community. Until next time, this is Elon Musk 24 Hours, keeping you connected to humanity's spacefaring future. "1,000 rockets per year. That's Elon Musk's audacious vision for SpaceX's Starship program. A launch cadence that would completely transform humanity's access to space. But there's been a critical bottleneck standing in the way: launch infrastructure. You see, SpaceX has been rapidly developing Starship prototypes, pushing the boundaries of what's possible with each iteration. But without enough launch towers, even the most advanced fleet of rockets would sit grounded, waiting their turn. A single launch tower requires extensive refurbishment after each mission. Cooling systems checked, structural integrity verified, and launch mount repairs completed. The turnaround time is simply incompatible with SpaceX's ambitious launch schedule. Now everything is about to change. SpaceX has been quietly working on a second launch tower at Starbase, featuring a revolutionary Chopstick system, massive mechanical arms designed to catch returning super heavy boosters and Starships midair. This engineering marvel stands near